Welcome to a gentle introduction to R. My name is Jonathan. I am a scientific assistant slash course assistant at University of Bonn's Geoinformatics workshop, which is a service by the Department of Geography. I am responsible for this course, which will be held in person too, and this is the online instructional equivalent. But if you can't attend in person because you're not a student of University of Bonn, you can also just follow these materials and everything provided by me, and you will still have the more or less same course experience. This course was made for people with no prior programming experience, so people who had no contact with any programming language before. So even if you're not a geographer like me, or like most of the participants in this course, I think you can still learn a lot. And I think we start by giving away my contact details, or rather not my contact details, but the one from the Geoinformatics workshop, which is this email address, geomaticfragen@geo.uni, what is it, a score, underscore, how do you call this? Bonn.de, which is the email address. At this moment, I am responsible for it. At some other point in the future, somebody else might be responsible for it. So keep that in mind when addressing in the email. But this is the email address by the Geoinformatics workshop. And this is primarily the way to reach out to me. I will try to answer YouTube comments, but I cannot promise that I will answer them in like 1 year or 2 years or whenever you're watching this. So yeah, feel free to contact this email address if you have any questions regarding the course, regarding future courses maybe, or anything geoinformatics and GIS and remote sensing related. And we start by having a little bit of a pitch for R as a programming language, and maybe also for programming languages in general. So why should you care about learning this language at all? And I think the first and foremost argument is that R was made for quantitative analysis, primarily statistical analysis, including geostatistical analysis. So if you want to do anything in that, R is like a primary address to go to. I've included here a picture of a supervised classification that I did in my own bachelor thesis. In the supervised classification of rooftop solar arrays was primarily done in R. So that's something that's very doable, but also other statistical operations can just be performed in R, like simple linear regression and multivariate analysis, and distribution analysis, and testing hypothesis, like statistical significance tests, for example. So all of this can be done in R. And on top of that, you can also use R as a table calculation program or table calculation and manipulation tool, kind of like Excel or OpenOffice Calc. And then you have the majority of your analysis in a single environment, which is really helpful and handy. But if you're not interested in quantitative analysis, which apparently some people are not, I know it's hard to believe, but some people are qualitative researchers, for example, and are not interested in such things. I think R has still some stuff to offer you, maybe not as much as someone who's really into statistics, but you can also generate really pretty plots and figures in R. I won't claim that these are the most pretty plots and figures that were ever created in R. These are just 2 examples from a seminar report I gave in. I handed in at some point, so it's unpublished. But I think if you use, for example, Excel to create plots or figures, and that might be just my personal bias, but I think you can always see that it's an Excel figure, and with R and also other programming languages, for example, plots created in Python using matplotlib or something like that, it's much harder. It looks much more original. In many cases, it's much prettier, I think. And I prefer it, for example, to ready-made solutions like Microsoft software. But that's a bit of a personal opinion, but you can definitely use R to generate pretty figures. And then in addition to that, you can also use R, specifically R Markdown, to create pretty documents, all sorts of documents. That doesn't include or isn't limited to scientific reports. You can also create presentations if you want. You can create HTML, so the layouting, for example, for a website, if you want to create a website, based on documents, for example. These are some examples that I put into the presentation. The left one is just a starter template for a random R Markdown document. So this is how it could look. The other one is a title page from one of my seminar reports that I did a while back. This is absolutely not the top of the food chain. This is a very simple title, but I think it conveys the point adequately. You can create pretty documents. We don't learn this in this course. It's not part of this course, but you can definitely learn it. And then the most important selling point, I think, is that, and this isn't just exclusive to R, it's the thing with all programming languages, that using a programming language enables you to be in control of all of your projects and your entire analysis. And to illustrate, I've put here a screenshot one of my students sent me at some point of a Python error that they got when they tried to do a supervised classification in QGIS using the SCP plugin. The geographers of you know what I mean. So they kind of tried the same than here in this picture, a supervised classification. And then they entered all the parameters and they did everything right in their opinion. And they pressed the run button and they got this very obscure error that they couldn't interpret correctly because they have no idea what Python code was running in the background, because they were just using the user interface of GIS to make this analysis. But if you use the programming language that is behind this user interface, in this case it would be Python, then you don't have this issue because you solve the mistakes as they appear directly. So you are in complete control of your analysis at all times, which is, I think, a really strong selling point for learning coding, learning programming. To some degree, obviously, we are not computer science students, so we probably won't have the same expertise as somebody who's studying this for their entire life. But still, I think this sums up to a pretty nice list. You can perform quantitative statistical analysis of large data sets. How large they can be, it depends a bit on your the processing power you can allocate. If you have a really tiny ThinkPad, then it might not be the largest data sets available that you can process. You can create aesthetically pleasing plots. Again, what's aesthetically pleasing is a bit subjective, but I think you can create a very pretty plots if you want. And then you can format scientific reports using R Markdown. Not just scientific reports, but also any other kinds of documents you want to format. For example, you could format a book if you want, if you're writing wrong. You can do supervised classification and regression. And I think that's the case for most programming languages. The first one you learn is always a gateway to other computer science skills and other programming languages. So if you know a bit of R and then you try to learn Python, you will have a much easier time than if you're just starting anew. And then the last one is you have total control over your analysis. So how is this class structured? The class structure follows the five parts laid out in this table, which you will see in the YouTube videos in the naming convention. This video will be 1.1, and then the next one will be 1.2, and then the next one will be 1.3, and then at some point it will be 2.1, 2.2, 2.3, and so on. So I think that's it's fine. It's easy to understand. And the reason we have this is a bit to split this up, like thematically, but also because the real live equivalent of this course, the one we have in person, will be 5 days long. So that's a part of the reason why some of the topics are split in between. So we have spatial data 1, spatial data 2, but don't let that irritate you. And the way you will receive these tasks and topics and stuff we have prepared for you is by accepting GitHub Classroom's invitation. And this will create a personalized repository on GitHub. If you don't know what that means, that's fine. We will have a longer explanation on GitHub and Git and how to set this up for our studio in the next tutorial. So what do you need to participate in this course? I need a sip of water. Sorry. You need RStudio installed. RStudio is a programming environment. It's probably the most popular and most well-known IDE that is used to write or to create R scripts and to use R. We will talk a bit more about what an IDE is and what's the difference to regular R later. You need Git and you need a GitHub account, and both of these are required for version control. Again, that's something that you will learn in the next video, so don't stress out too much about it yet, but you need it installed. Then I have some general advice for you that we will always come back to, I guess, during the course. I put this here so it's easy to find, but this is mostly related to the coding itself. And the first advice I have for you is to always comment your code, especially if you are a beginner. It's really helpful. So commenting means that you put a hashtag symbol in front of a line, and then this line is commented out, which means it's not run if you run the code. So you just have a string, you just have a couple of words there that are not run as code, but it's just a comment, so you know what the code below is doing. And I recommend you always comment it if you're starting out. This has a very simple reason. If you don't comment your code and you leave it, I don't know, do some stuff and like save it, and then you come back 3 days later and it's not commented, you will, unless it's very easy code, you will have forgotten what it's about. So to prevent this, always comment. And then also, don't use abbreviations as variable names or just in general, because if you use them, then I mean it's not super bad if you use one abbreviation, if you are somewhat consistent with that. But if you use a lot of abbreviations in a really long script, you will inevitably, in the same situation, if you come back like a couple of days later or a week or a month, you will have forgotten what the abbreviations mean. And also, if you share your code with other people, they don't have an inherent understanding of what your abbreviations mean. So you should stay away from abbreviations as much as possible. Then that's a very normal software thing. Don't forget to save, and don't forget to commit. This should say push. Don't forget to commit and push to GitHub frequently. What this means, again, we will discuss in the next video. But don't forget to save your stuff to prevent loss of data, for example, or loss of progress, to be more precise. And then another one is be bold. You cannot break anything, or it's really hard to break anything in R or in programming languages in general, especially if you use GitHub. You cannot break anything. You can always revert to an earlier version. You cannot bring your data directly because every change you do, you apply to the data is only applied inside of the programming environment. And unless you export it and overwrite your original data, you cannot ruin your original data. So be a bit bold, just try things out. Don't stress about like possible mistakes. Programming is not about avoiding mistakes; it's about fixing them. I'd say. Then you can use the help function. We will talk about that in another lecture. So not important now, but there is a function that opens the documentation for functions and kind of helps you out a bit if you get stuck. And then that's a bit of life advice, I guess. So very general, very broad. Be persistent when you face problems, when you face error messages, warning messages, and so on. You can find solutions for most problems just by going through advice you find on the internet. But you have to be a bit persistent and to try, have to have the guts to try different stuff out and to, yeah, endure the frustration of not finding the answer right away. And then also a bit more life advice, take frequent screen breaks. So don't stare at the screen for like 8 hours straight. Take breaks, drink a lot, stay hydrated, and yeah. And if you need help and you are participating in the live equivalent of this course, you can of course ask me or the course assistants who will provide help in this course. But you also have the vastness of the internet at your disposal. On the internet, you will find tutorials, you will find even video tutorials, you will find forums, blogs, and so on. And you're not the first people who learn this programming language, so you can expect to find more solutions just by Googling a bit. But if you have a really persistent problem that you can't fix and you did a lot of research on trying to fix it, and have tried everything that you can and you are at your limit, then you can go to Stack Overflow, which is a forum where programmers can ask programming related questions to other programmers. And there you can ask other people who are more experienced than you. But if you want a productive answer, you should adhere to these tips and some other guidelines that they have on their website. But I will just present a couple of tips that you can should keep in mind when you post on Stack Overflow. And the first is you should ask like you'd ask a busy colleague. So be quick, be concise, but provide all the information relevant to understand your case. It's not bad to show that you already tried a couple of solutions that didn't work or why they didn't work. It's not bad to show that you put effort and research into trying to solve this problem. So people understand that there is a need to help you. But also you should introduce the problem and everything related to understanding this problem and all the necessary details before you start talking about code even. And then you provide code, and the code should enable others to reproduce your problem. And this doesn't mean that you can just take your problematic code and copy it over, because other people cannot reproduce usually what you're doing because they don't have access to your data. They don't know which data you're working with. They don't know the greater context of your studies or what you're doing in R. So you have to provide, for example, a code sample, a way of reproducing the code, or provide the code that you used in this problem. And then you have to include all the relevant tags. You can, if you ask a question, you have to put text down there so it's sorted on the website. And if you're asking a question about R, you should use the R tag, for example, so other people know this is a question about the programming language R and not a Python question and not about anything else. And then my last point is a point a bit related to the course, but it's mostly personal thing I wanted to add, and that is that everybody can learn programming, even if you have no prior experience. And I think it's important to address that because the belief that some people are inherently good at programming and are good at working with computers, the computer people, and some other people can't do that, is very persistent, and even at university level and even among instructors. and not just the students themselves. So to show that this is wrong, I have included a study here where researchers surveyed the distribution of computer science grades, whether they are bimodal or not. Bimodal means you have two modes, so you have one peak at the one side and one peak at the other. In the case of grading, this would mean we have a lot of people getting really bad grades, and this would be the non-computer people who are inherently bad at programming. And then we have a lot of people who get really good grades, and these are the computer people. So this is often expected if you look at computer science grades, but by researching these grades or the grade distributions, they showed that a very, very slim minority of these courses have a multimodal grading distribution, so that computer science courses are usually graded like every other course, with a lot of people in the middle, and then some people with very, very bad grades and some people with very good grades. In addition to that, they also analyzed the personal bias of computer science professors who did these lectures or courses, and they found out that these instructors were more likely to label distributions as bimodal if they believed that some of the students are innately predisposed to do better at computer sciences. So the results suggest that this bimodal grades distribution is instructional folklore in computer science. So it's something that's a very persistent belief that's not true at all. Everybody can learn programming. It's not something that you're genetically predisposed to learn. Of course, some people have an easier time learning it, but that is mostly because they also worked with computers before or did some other software before or good analytical thinkers. But that doesn't mean that you're, I don't know, predisposed to perform well at programming. That being said, it's okay if you don't want to learn it. It's a considerable time and effort you have to invest. If you do not keep using the skills you acquired in this course, if you do not extend on them by incorporating them into your research practice, for example, by writing a degree thesis using coding or starting a project using coding, you will inevitably lose the ability to do so. And I think that's the same with every skill that requires training, including, I don't know, writing or analytic reading or playing an instrument. And then, in addition to that, if you have no fun learning programming at all, if solving coding issues gives you zero joy and only frustration, it's probably not worth committing on programming as a method or as a part of your career. It's absolutely possible to pursue a career in qualitative research and never touch coding and programming, and many people do so, and it's a valid life choice, I'd say, even though I think many people would greatly benefit from these skills. But yeah, I do not want to force you to learn anything here that you don't want to learn. If you do not have any joy at all, it's probably better to quit. Okay, I think that was already quite a lot for a first session. I'll try to keep these lectures below 30 minutes. It might not always be possible without weird cuts, but I will try to.